Okay, now, you need your calculators out. If you don't have your calculators out, don't bother staying. You can just go to your next period early. Yeah, try it. Okay, so let's just do that. I'm gonna go through this quickly. Okay? You need your calculators out. Be ready to calculate when I say so. Very simple calculations, okay? Now, first thing you do is you put in your masses. Remember, this is a stoichiometric equation. Complete balance formula equation. It's called a stoichiometric equation. Yes? Okay. 300 grams of this, right? Okay, now, but this column, I just want to simply put, and there's a reason why I'm doing it this way. I want you to put the molar masses. Simple, right? What's the molar mass of nitrogen?
28.
28 to
17.
Good. What is the mass in grams? This is given, right? That's given, right? So if you have 300 grams of that, how much hydrogen do you need? Well, let's see. Let's do it. Let's say nitrogen to hydrogen equals, is that coming out? No. Okay. Nitrogen to hydrogen is going to be 28 to 6. That's your constant ratio. Thank God for Dalton, okay? And that's going to be what? What's given?
300.
300 over x, right?
Yeah.
Solve for x. 6 times 300, 1800.
Yeah.
Okay? Divided by 28.
64.
Figure by 30 and you get about the approximate answer. What is it?
64 point, 64.2.
All right, we need, did you both got it? We have verification. So what did you get? I'm sorry?
64.28.
All right, we're going to say just 64. We're just going to go crazy. Okay? We're just going to round. Okay, now, you can do the same thing, but say nitrogen to ammonia and do the same thing. Or you could observe conservation of mass, the law of the conservation of mass, right? Okay, which is this side equals that side. So it's going to be 364. Yes? Am I all right? Hey, listen. Don't let me turn off that camera with a mistake on the board. Yes? Very simple calculations, yes? Okay, now. Can't do volume yet, can we? What do we need to do? Because you always have to go through what? Moles, right?
Yeah.
You can't convert from mass to volume. You always have to go through moles first, right? You can go from moles to anything you like. But if you're given a mass, you can't do a volume unless you go through moles, yeah? So you got to do moles first. Now this represents, this is why I did this. This represents a mole, doesn't it? But just in mass speak, right? So 300 divided by that. So how many moles in that term? In terms of mass, in terms of mass, in terms of mass, how many moles are in there? So there's going to be about 10. A little more than 10, right? So how many?
10.7.
What is it?
10.7.
So 11. Is that all right? Can we say 11? Okay, good. Now, so then, how many are here? 32. 32. Excellent. Oh, really? So how come you haven't contributed?
I was about to, but
Oh, you're about, okay. All right, you're about to. That's fine. I like about to's are good. 364 divided by 17 is what?
21.
21. All right, now look at this. Answer me this. Riddle me this, Batman.
Yeah.
11 moles plus 32 moles, right?
Yeah.
Equals 21 moles?
No.
No.
Is that right then? Is there something wrong?
Yes, it's 43. What?
So it should be 43 moles.
Yes.
So this should be 43. So I did something wrong here, right?
Yes.
Right? Or you could simply say, Mr. Darcy, Mr. Fathead, you could say, well, wait a second. If that's true, how come I have 4 moles on this side and 2 moles on that side in the stoichiometric equation? Why? Well, I'm going to tell you. You ready? The law of the conservation of mass, not moles. It's the conservation of mass. Get it? Good. Okay. 35 years of listening to students' mistakes. Trust me. That is common. It's the conservation of mass, not moles. All right, now. What's the volume of 1 mole of any gas at STP? We're assuming STP. I didn't say that, but what is it? 22.4. So what would be the volume of 2 moles? 44.8. Excellent. So what would 10 moles be? 224. Good. I'm glad, Andrew. That's wonderful. Okay, excellent. Now, what about 11 moles?
246.4.
246.4. Can you read that? I can read it. Okay, 246. We're rounding to ones place. Okay. 32 divided by 2.
716.8. Whoa. Wait, what?
Hold up.
I'm sorry, 64. Sorry, multiplying. Sorry.
Yeah. 716.8. So 717.
I'm sorry. What am I doing? Sorry.
Moles times.
I'm like dividing by 2 I'm like rushing through this and I'm losing my mind. 32 times 22.4.
717.
717?
Yeah.
All right. 21 times, sorry, I'm going over here again. 21 times 22.4.
470.
470. Now, that's absolutely correct. And just to remind you, this is given. Okay? Now, what you can do is, this is what you can do. You have literally 9 problems up there because you could erase all this, right? And put another, put this in instead, 717, see? You could start with that volume and get everything blank, right? And then you can see if you can find all the values, yeah, without referring to the paper with the solutions, you see? So now you have, this could be 9 problems, yeah? These are just Shema, okay, this is usual. This is what people do. I'm telling you why I want to make that clear. This is a very common mistake. Are you ready? You ready? You ready? You ready? Okay. That when they do this mass thing or the mole thing, say, right? Instead of dividing, like this was going to be what? This was 300 divided by 28, right?
Yeah.
Now let's say 64 divided by 2, right? Right? That's how many moles there are. So if you have 64 grams of hydrogen, right? You can divide by 2. That represents a mole, right? So that's how many moles you have, right? So this is what people love to do. They love to divide it by 6. Well, that's the hydrogen value. Yeah, that's the hydrogen value, of course. Okay? It's not a problem. Okay? Most excellent, dude. Okay? All right? So, I know, everybody looked at, sorry, my apologies. You kind of look like that voice, actually. But you don't sound like that voice, but you look like that voice. There's another teacher in the classroom, and he looks like, you know what I mean? Like, you should talk like this, you know? Like, I'm not kidding, man, you know? Sorry. But he's actually extremely intelligent, and probably brighter than me, but just really, I'm going to quit while I'm ahead. Yes, Andrew! Bless you.
Were you trying to reference Bill and Ted's Most Excellent Adventure?
One of my favorite movies. The second one was terrible. The first one was most excellent. Dude. Okay, now, so, you get it? Any questions on this? Yes? Hey, listen. Hey, it's only Tuesday. I'll see you on Thursday. I was about to say have a great weekend, okay? And I have people smiling, so we're cool, baby. We're going to do the same thing. But you know what we're going to do? We're going to do a lab, man. We're going to do a lab. Yeah! All right, we're off.
Why are you calling me pink?
Wow.